Untitled Chapter 4 is exponential and log function. So basically this section we're going to solve for x. X can be on the base or on exponential. That's a formula that we cover in intermediate algebra. Y equal to log base a of x if and only if a to the y equal to x. So when you have if and only if, you can go both direction. So let's look at our first example. I have 2 to the x is equal to 4 to the 2x plus 1. If you can make them the same base, that would be the first approach. So this is base 2, this is base 4. I'm going to make them the same base. So I'm going to write it as 2 to the x equal to 2 square to the 2x plus 1. Alright? Now they're the same base. Then I will make them use the exponential property to simplify this a little bit. So I will have 2 to the x is equal to 2 to the 4x plus 2. They have the same base. They equal, so the exponential should be equal. So we have x equal 4x plus 2. Now it's just linear. You can solve that. So this is 3x is equal to negative 2. So x would be negative 2 over 3. Alright. Look at the next one. Again, I can make them the same base. So I have 2 to the absolute value of x is equal to 2 to the 4th. So absolute value of x would equal to 4. So x would equal to plus or minus 4. So try to make them the same base if you can. Unless you cannot, then you're going to use some of the property here. Look at the next one. I have log base 5 of x equal to 2, and I need to solve for x. So I'm going to change to exponential form. So I'm using this one here. So I'm going to have 5 squared equal to x. So x is 25. I'm rewrite it as exponential form. So this is the log form, this is the exponential form. The next one is the basic property of log. For any base a greater than 0 and a is not equal to 1, if you have log base a of a is equal to 1, log base a of 1 is equal to 0, log base a of a to the x is equal to x for all x. And a raised to log base a of x also equal to x. So let's look at the next example. I have log base 9 of 81. So I'm going to use the third property here. I'm going to rewrite it as log base 9 log base 9 squared, because 9 squared is 81, so this is equal to 2, right? So the answer is 2. The next, I accidentally did it. Let's say I didn't do it. So let's say I have 3 log base 3 of 5 minus log base 2 to the negative 3. So this one, I'm going to use the fourth property here. You see this is 3 log base 3 of 5. So it's going to equal to 5. Minus the second one, I'm using property number 3, log base 2 to the negative 3 equal to negative 3. So I'm going to have negative 3 here. So it's 5 plus 3, which is 8. Alright, let's see more example. At our rule of log, right? The first one is called product rule. If you have log base A of m times n, if you want to write its expanded form, is log base A of m plus log base A of n. So the left hand side is called the condensed form, and the right hand side is expanded form. The quotient rule, you have log base A, m over n is going to be log base A of m minus log base A of n. The power rule is tell you that if you have exponential, you can bring it up front. So let's look at our example. Now they want you to write this as expanded form. So I'm going to use, first I'm going to use property number 2 here, quotient rule, because it's in terms of division. So I'm going to have log square root of x squared plus 1 minus log of x plus 3. That's the quotient rule. Alright, next I'm gonna rewrite this as exponential. So I'm gonna have log of x squared plus 1 to the 1/2 minus log of x plus 3. So far so good. Now I'm gonna use the power rule. So I'm gonna bring the exponential up front. So it's gonna be 1/2 log x squared plus 1 minus log of x plus 3. So this is my expanded form. Now we're going to write that as condensed form. So basically we go from the right to the left. This one we go from the left to the right. So let's see. I'm going to rewrite this. Alright. So this is 1/3 log of x. I'm going to use the power rule here. So this is going to be minus log y squared plus log z to the 3rd. I'm using power rule. I'm going to use power rule again. I'm going to bring this over here. So I'm going to have log of x minus log of y squared plus log of c to the 3rd raised to 1/3. Right? Now I have plus and minus. So I'm going to use the product rule. The plus will be multiplication, the minus will be the division. So I'm going to have log x times c, because this is plus, these two are plus, actually c to the cube, divided by y squared, because this is minus, but everything to the 1/3. So that is my condensed form. Next one is change of base. It said that if you have log base b of x, you can change to any base. Alright, I changed to base a. A lot of calculator, if you see log, that's log base 10. Ln is log base e. Some advanced calculator you can do any log, any base, but a lot of basic one it can be base 10 or base e. So you can change to base, any base, then it's going to be log base a of x divided by log base a of b. Let me change to base 10. Alright, if I change this to base 10, I'm going to have log. If I don't put 10 here, it means base 10. Base 10 is common base, alright? If I don't put anything, you just assume it's base 10. So log base 10 of 5 over log base 10 of 2, alright? So if you plug in the calculator, you should get about, let me look, 2.322. I use base 10, or you can use base e. So you're going to have ln 5 over ln 2, which is about 2.322. All right, let's look at more example.